So this is the continuation of lecture 11, warehouse space and layout planning, lecture 11, part 1 for IE 4355 facilities planning. And in the previous video, we cover an introduction on warehouse operations. And we would discuss, the last thing we did was to discuss an example on how to determine the storage space requirements in number of loads. So for a manufacturing firm, we were determining the reorder point, the maximum quantity to be stored, and the average quantity to be stored. So in this second example, we are focusing on illustrating the difference between how you plan for a randomized storage and the difference when you compare to a dedicated storage. And we're gonna do that based on this example, in which suppose you have 6 products are received by a warehouse according to the schedule in table 1. So this schedule has multiple periods. So you go from 1 to 24. These are time periods. And then you have different products, 1, 2, 3, 4, 5, and 6. And this last column basically is showing the aggregate. So it's the summation for all the products. So for this first period, we are receiving 24 items for product 1, 12 items for product 2, 2 items for product 3, 12 items for product 4, 11 items for product 5, and 12 items for product 6. So if you sum all those numbers, then the aggregate in terms of the total of items that you receive for all products is 73. Okay, and that is repeated for each period. So again, by summing the inventory levels of the 6 products per time period, the aggregate inventory level is obtained. So 24 plus 12 plus 2 plus 12 plus 11 plus 12 equals 73. When you plan for dedicated storage, the required space, as given in table 1, equals the sum of the maximum inventory level for each product. In this case, that would be 140. So remember that for dedicated storage, we are always saving the space for a specific product in the warehouse. So if you have an area, that area will never be occupied by another product. So when you plan for a dedicated storage, then you have to make sure that you have enough space for the product when it arrives, for every single item that you have in your warehouse. Okay, so when you plan for dedicated storage is that you want to make sure that you satisfy and you have enough space for your maximum possible number of items that can arrive for that product. So what you do, you go product by product and you look at your history for all time periods. So we're going to look at product 1. And we're going to look for the maximum value. So I think for product 1, that will be 24. For product 2, that will be 36. For product 3, that will be 8. For product 4, that will be 24, unless there's another number. For product 5, that will be 24, I believe. And for product 6, we also have 24. So the summation of the individual maximum inventories should be equal to 140. So let's double check that. So this plus this equals 60. This plus this is 68. Then we have 92. 96 plus 20 is 116. And then plus 24, that's 140. So the summation of this number, the sum of the individual maximum inventories is 24 plus 36 plus 8 plus 24 plus 24 plus 24, and that is 140. So for a dedicated storage, you will need the maximum inventory level for each product. So you will need 140 pallet positions when you plan for this dedicated storage. When you plan for a randomized storage warehouse, the required amount of space equals the maximum aggregate inventory level. So that's why we have that last column in this table, because we want to find what would be the largest amount. And the largest amount for the aggregate column is 105. So with randomized storage, the required amount of space equals the maximum aggregate inventory level of or 105 pallet positions. So in the randomized, you are not fixing any area for storage in terms of different products. You just want to make sure that you have enough space in which you can accommodate the products in a randomized way. Okay, so you can see that these are two different, and there's some savings in terms of space when you look at the randomized storage when compared to the dedicated storage. So in this example, the dedicated storage requires 1/3 more pallet positions that does the randomized storage. To maximize throughput when using dedicated storage, SKUs should be assigned to storage location based on the ratio of their activity to the number of openings or slots assigned to the SKU. The SKU having the highest ranking is assigned to the preferred openings and so on, with the lowest ranking SKU being assigned to the least preferred opening. Because fast movers are up front and slow movers are in the back, throughput is maximized. So the idea here is that with this dedicated storage, you have the space in the warehouse and you are trying to accommodate those products or those items in locations that are easy to access if they have a high volume of demand. For those items that are not moved as fast, then you want those to be located in those positions that you don't have to look for them very often, so you can put them in locations that are not visited a lot by the picker. So fast movers will be up front and slow movers will be on the back. So in ranking the SKUs, it is important to define activity as the number of storage by retrievals per unit time, not the quantity of materials moved. Despite the greater throughput of dedicated storage, it is not used as often as it should be. One reason is that it requires more information to plan the system for maximum efficiency. When conditions change significantly, items must be relocated to achieve the benefit of the dedicated storage. Hence, randomized storage is more appropriately used under highly seasonal and dynamic conditions. When many SKUs exist, dedicated storage based on each SKU may not be practical. Instead, SKUs can be assigned to classes based on their activity to space ratio. Class-based dedicated storage with randomized storage within the class can yield the throughput benefits of dedicated SKU storage and the space benefit of the randomized SKU storage. Depending on the activity to space ratios, 3 to 5 classes may be defined. So suppose in this example, suppose the storage area for the warehouse is designed as shown in figure 5. A single input-output point serves the storage area. All movement in full pallet quantities, and the storage area is subdivided into 10 by 10 storage space. 3 classes of products, A, B, and C, will be stored. Class A items represent 80% of the input-output activity and have a dedicated storage requirement of 40 storage space, or 20% of the storage of the total storage. Class B items generate 15% of the input-output activity and have a dedicated storage requirement of 30% of the total, or 60 storage space. Class C items account for only 5% of the throughput for the system, but represent 50% of the storage requirement. Assuming lift truck travel between the input-output point and individual storage space can be approximated by rectilinear distances between the dock and the centroid of each bay. Distances are as shown in figure 6. So those distances are measurement from this point, which is the dock. And then as you move farther from the dock, if you use rectilinear distances, then that is going to increase. So for example, 10 are those bays that are located close to the dock. But if you move farther away, let's say 20 is here, and then as you move farther away, you get the 30s, and then the 40s, the 50s, and so on. Based on the ratio of input-output activity to dedicated storage requirement, the product classes will be placed in the layout in the rank order A, B, and C to obtain the product layout. The expected average distance traveled for the dedicated storage layout shown in figure 6 is 53.15 feet. So as you can see here, we have 3 different areas that are used to accommodate those 3 classes that we defined initially. So for A products, you will place them in this area that have marked as red, and then B classes will be on the next area, and then C farther away from the dock. If randomized storage is used such that each bay is equally likely to be used for storage, then the expected average distance travel will be 100 feet. However, with randomized storage, a total storage requirement of less than 200 bays is anticipated for the reasons discussed previously. The exact storage requirement will depend on the demand and replenishment patterns for the 3 product classes. Even though the storage requirement for randomized storage is not known, it is possible to compute an upper bound for storage. It yields an expected distance travel equal to or less than that for the dedicated storage. To do this, storage bays are eliminated from consideration in reverse order of their distances from the input-output point, and expected distance values are computed. The process continues until a sufficient number have been eliminated. For example, 138 storage bays or 69% must be eliminated for randomized storage to yield an expected distance travel equal to 52.9. So that's the discussion for the first part of warehouse space and layout planning. In the next lecture, we're gonna go deeper into some problems. So So thank you.